and welcome to my presentation of creating innovative uses of technology. My name is Justin Null, and this video is for Central Michigan University's course EDU 709 and focuses on the use of flip video in the classroom on two separate projects. Just as a preface, my two projects are completely unrelated to each other, two very separate lessons and projects for the use of this technology. Rather than building a unit where one lesson follows the other, these are two separate content areas. My first lesson is a math project for 8th graders, and their task is to redesign a standard 12-pack box of soda. They work in groups to build new designs of the 12-pack box to minimize volume, surface area, or both. I always begin with this picture and pose the task to them as look at all the empty space inside this box of cans, and also discuss how companies have to pay for the cardboard they use to pack their boxes, to pack their cans in. Technology involved in the project is a wiki to report out their findings, to report on specific things that I ask of them, and also a flip or digital video to record a sales pitch where students decide on their best box and try to sell that idea to soda distributors and manufacturers. The rationale behind this project is mainly driven by the Michigan grade level content expectations for 8th grade math, and that is knowing and understanding and using formulas to find surface area and volume of cylinders, prisms, as well as maybe some other solids in there like pyramids and cones. And this project also touches on the ISTE nets for students, Standard 1 for creativity and innovation, where students apply their knowledge to generate new products, and Standard 2 for communication and collaboration. Through the wiki, students interact, collaborate, and publish with their peers. And through the video portion of the assignment, students communicate information and ideas with an audience through a variety of media and formats. The project itself starts with students working in groups of 3, and they begin with measuring a standard 12-pack soda box and get baseline numbers for the surface area and volume of that box. I always have a Wikispaces wiki set up so that students can join and create a new page within that wiki for their group to report out on their work. Groups then design. They do a lot of time planning and a lot of time building these 3 new prototype boxes. They actually build them with cardboard. Most of them use cans inside, with their goal of reducing the surface area, volume, or both. Each group creates a page inside that class wiki where they were going to report out on their work. On their wiki page, groups are going to provide me with the answers to a few specific questions and things that I need from them. First being a short description of their design, and I always have them write 2 or 3 sentences describing how they came up with their idea, just describing what their box looks like. They're going to include a photo of the box, a digital image on their wiki page, with the name of the shape, whether it's a rectangular prism, a triangular prism, or we do our best if they come up with any wacky designs that are pretty irregular and don't have a specific mathematical name. They also provide me with the surface area of the box and how that compares to the original. Did they save money by using less cardboard? Does it use more cardboard than the original? And they also include the volume of the box and how that compares to the original. Does it take up more or less space? I also have them finally provide me with at least 2 pros and 2 cons of their designs. Typical pros and cons are whether or not the box is stackable on a grocery store shelf, whether or not consumers will like it, whether or not it saves on surface area or volume. Just a short story about a project I had submitted last year. A group turned in a very long cylinder that was 1 can in diameter and 12 cans stacked on top of each other, all in one big long single tube. Their pros were obvious. It wasted zero space inside the box. They had the volume of the box was the exact same volume as the 12 cans, so they achieved one of the goals of the project. But their list of cons was very long, noting that it wasn't stackable, you couldn't put it in a grocery cart, it wouldn't fit in a refrigerator. They were really had a lot to talk about with their design. After all that analysis is done of each one of their boxes that they build, and they report out on the specific items that I need, the groups select one box that they think is their best, and they try to sell that to soda distributors and manufacturers. They do that through a brief 2-minute long or so video using a flip camera where they highlight the benefits of their design and really focus on trying to sell their idea. I always have them, because I'm a math teacher and because it's a math project, justify their claims mathematically and provide some proof and some good sound reasons why someone should invest in their design. Then they'll upload that video to a video hosting site and embed it on their Wikispaces page along with all of the other information that's required of the project. The students need continual access to computers with internet access because there's some photo and video uploading for this. High-speed access is almost a requirement. It would be very difficult to do without it. They will also need a flip camera or another digital video camera, as well as digital still cameras to take photos of their boxes. Students also will need accounts with Wikispaces or whatever your wiki provider of choice is, as well as the video hosting site that they'll use to upload their video. Required of the teacher first is time and patience, because this project requires about 2 full weeks of class time to complete if you're going to really expect quality work of students between building the boxes, planning them out, analyzing them all, as well as reporting out on a wiki and filming their videos. Teacher also needs some basic technology skills to be able to set up a wiki for the class, allow students to join or invite them. Teachers also need to be able to troubleshoot some of the hardware involved, be familiar with the digital video equipment and digital cameras involved, and be able to help students with any problems that might arise as far as uploading images or videos. Obviously, teacher needs some content knowledge of the formulas and how to use them. And the big one here is that teachers have to be able to take a step back from the center stage, away from being the instructor to being more of a project manager. Let the students be creative. Let the inquiry process happen. It takes some patience, it takes some practice, but it is well worth it if you can step back and just let the students work on a task. I always try to point students towards the answer but never give it to them, and I love watching the frustration in them as they fight and work together to get the correct answer to a problem that's just really bugging them. The advantages of this project is that it's very hands-on, it's extremely relevant to students, and it's engaging. Their work's serving a practical purpose. It's going to be shared with the public, and they're engaged much more than they would be just memorizing formulas and calculating area and surface area and volume on a worksheet. This project also addresses nearly every level of Bloom's taxonomy, from creating the videos, building the boxes, evaluating their work, deciding whether or not it's a quality product, analyzing the results to decide that, applying the use of formulas, and even down to simple calculations, and understanding what surface area and volume actually are. Disadvantages of this project is that it's time consuming, number one, but it is worth it. If you don't have access to high-speed internet, which almost everyone working at a school will, you might need a little bit more time. You might even need more time if students don't have high-speed internet at home. You need to provide that for them at the school. Another disadvantage, and this is the big one, is that there is a hardware requirement. It does require still digital cameras, digital video cameras. That might be an issue. One possible solution, and I've used this in the past, is to encourage the use of mobile phones or other mobile devices if they don't have access to a flip or a digital camera. Depending on school policies, this might be an issue for you, but I love watching students do quality educational work with these phones under my supervision. I'm always pleased when I see this. I'm going to stop this presentation right now and continue on in another video to explain my second lesson for this project.